Welcome, this is the 2.5 Ready Set Go homework solution. Alright, so what we have here is the ready part. The ready part says to write the equation of a line in slope-intercept form, which is y equals mx plus b, using the giving information. Alright, number one, you have m equals to -7, b equals to 4. Very straightforward. You write the equation, slope-intercept form, y equals mx plus b. Here I color code it to make sure that you see where I'm making the substitution, okay? Right? So the red is the slope part, which is -7, and the 4 is the y-intercept, which is green, okay? The color coding there is for you to see where I'm making the substitution. Very straightforward. 2, same thing, right? There's my slope, there's my y-intercept. I write the equation, y equals mx plus b, and I plug in the values, okay? Right, same thing with 3. Okay, there's not much explaining. You're just plugging into the values. You write the equation, you plug it in. Okay, that's slope-intercept form. All right. So number 4, it says to write the equation of the line in point-slope form, y equals m parentheses x minus x1 close parentheses plus y1. Okay, using the giving information. Okay, I don't really like this form. Okay, in slope-intercept form, right? So I'm gonna show you. Okay, all right. So you have m, which is the slope, and you have a point. Okay, I can label the point x1 equals to 0 and y1 equals to -7. This is the notation of this is the first point in the x direction. This is the first point in the y direction. All right. Point slope form. This is the traditional format of the point slope form. It's y minus y1 equal m parentheses x minus x1. Okay, you can simplify this to get to this side, but this is the traditional formula format. Okay, all right. So again, you're making the substitution that m is the slope. That's where you're substituting in the 9. y1 here, you label it as -7. And x1 here, you also labeled it is 0. So again, you label the points, you plug it in. Here you could simplify. A negative times a negative is a positive. So y plus 7 is what simplifies to the left-hand side. And on the right-hand side, you never write that -0, so it just becomes 9x. Okay? Right? Now you want to get the y alone. So I subtract 7 to both sides. Gets me y equals 9x minus 7. Okay, this would be the correct format. Alright, next we have 5. Again, we have the slope, 2/3. We have a point. Once we have that point, we label the point. Right, x1 equals to -6, y1 equals to 1. All I'm doing right here is labeling the points. Next, this is point slope form. Again, that's the format. Make your substitution. 1 goes in here directly, right? The x minus 1, -6. Plug that in right where it is. 2/3 is right there, right? Remember, when I substitute, I tend to like putting in the parentheses, okay? It helps you out. So, y minus 1, that's what my left-hand side is. So this minus a negative is actually a positive, right? Because a negative times a negative is a positive. So this whole inside simplifies to just x plus 6. Right? Get y alone by adding 1 to both sides, so it looks like this. Okay. Some of you might want to start in this format. It's up to you, but this is to the traditional format of the point slope form. All right, 6. Here's my slope. Label my point. x1 equals to 4, y1 equals to 7. Write my point slope formula, make my substitution. Okay, right? y1 plugs into 11, x1 is 4, substitute that in, m is -5. Right? Simplify. Right? So it's y minus 11, right hand side -5 parentheses x minus 4. Okay, add 11 to both sides to get the variable alone. All right, number 7. Right? Notice how I already have the m here, right? Which is the slope. Okay? Here I'm given the point. So I need the slope first of all. How do I do that? Okay? I label the points first. I have x1, y1, and x2, y2. Okay, I just label that. I call this x1 and y1 because this is my first point. Okay, I call this x2, y2 because this is my second point. All right. So here you go. M equals y2 minus y1 over x2 minus x1. This is just the slope formula. You make that substitute in. Make sure you're very careful. Minus a negative. Okay. Again, when you make this substitution, use the parentheses. That's how you avoid making your mistakes in terms of the negative. Okay. 10 minus negative 5 is just 10 plus 5, which is 15. On the bottom, negative 3 minus 2, which is negative 5. If the negatives play with you, just plug into your calculator. You should get m equals to negative 3. Okay, plug into your calculator. Avoid the negative mistake. Alright, point sloped form because now I have a point. Okay, I have a point here and I have a slope here. That's why you call it point slope form. Make that substitution. So m is negative 3. That's what you just calculated. And you can grab this point, x1 and y1. Okay? And it becomes like the previous problem here, like 4, 5, and 6. Okay? So this minus the negative 5 just becomes y plus 5. Right? Okay? Then subtract 5 to both sides because you're trying to get the y alone. Alright, same thing here. 8, we have the first point, so we label the first point. x1 equals to 0, y1 equals to negative 9. Second point, that's why we use that subscript of 2 here. x2 equals to 3, y2 equals to 0. Calculate your slope first. You should get a value of m equals to 3. Okay, you can also graph this if you want to count visually. That works as well. There's your point slope form, plug in the values, and get y alone. Okay, the procedure just repeats itself. Okay, there's nothing new. Same thing with 9. Here's your point, label it. x1 equals to negative 4, y1 equals to 8, x2 equals to 3, y2 equals to 1. Write your slope formula. Again, write the formula. Do not plug things in. Write the formula. Now you make the substitution. y2 is 1 minus y1, which is 8. On the bottom, x2, which is 3, minus y1, which is a negative 4. Okay, that's why I put in the parentheses when I make that substitution. M equals to negative 7 over 7 simplifies into m equals negative 1. Once I have the slope, I also have a point. I can use point slope form. Make that substitution in using this point because do you see the subscript? y1 and x1. That's why I use these points. Okay, a negative and a negative becomes a positive, so that is plus 4. Get y alone. That's how it looks like. Okay. Alright, next. 8. Make a graph of the function based on the following information. Add your axes, choose an appropriate scale, and label your graph. Then write the equation of the function. Alright, so the beginning value is 5, so that should be your y-intercept. I'm going to make that green. And it says 3 units smaller. It's going to be red, and that's going to be the slope. So I have it here. Why is it a minus 3? Because it is smaller, right? 3 units smaller, so that's a minus 3. The beginning value is 5. That's why the y-intercept is called 5. Beginning value, that's your y-intercept. Okay? Put in point sloped form. Y equals mx plus b. Make your substitution. Okay? Here I have the graph already out for you to show you. Now, some of you are wondering, how do you do it? Okay? So, there's a site called Desmos right here. Okay? All you have to do is once you go to the graph, right? Let me just move this over a little bit. Okay. Alright. Oops. Alright. So I could make it a little bigger. Right? So I'm just gonna grab this formula. Alright, where is Desmos? Alright. Plug it in. And make it large. Boom. Whoa. There you go. Do you see? It grabs automatically for you. There you go. Okay. Going down because it is decreasing. This y-intercept is 5. Okay, that's how you do it. Right? That's how it looks like after that. Okay, it is called desmos.com. Okay, and you can just graph it. Next, let's see. 11. The beginning value is 16. Beginning, that's the key word. That is your y-intercept. The value of 1/4 unit smaller is red. Okay, smaller means it's a subtraction. Plug it into your slope-intercept form, which is y equals mx plus b. M is negative 1/4, b is 16. Okay, here's the graph. Do you want to see how I graph it? Alright, let's pull up decimals. Let me grab the equation. So, alright, let me grab the equation. Alright, let's pull up decimals. Alright, cancel that out. Plug that in. Boom, there it is. How it looks like. Okay, it's decreasing. Starts at 16 here. Whoop, 16. Do you see 0, 16? Then it goes down to some points. Okay, do you see that? Where's the next intercept? Oh, that's a good intercept, right? That looks like a good intercept. Right? 12, 13. Ooh, that one looks also good. 4, 15. Right? There you go. That is 11. Okay. 12 should be down here, right? 12. Again, the beginning value is 1, so that is your y-intercept. We're going to make that green. The value is 10 times as big, so it's getting bigger, so that's a positive slope. So m equals to 10, b equals to 1, y equals mx plus b. Check out the colors, tells you where to substitute. Y equals 10x plus 1. If you graph it, it should look like that. Alright, again, I'm not going to show you in decimals because I already showed it before. Pull up decimals.com, insert the equation, and it should graph for you. Alright, it's going up because it is a positive slope. Next, the beginning value is negative 8. Let's make that green because that is your y-intercept because of the keyword beginning value. When it says 2 unit larger, it's getting larger, so that is a positive. So your slope here is 2. Beginning value here is negative 8. Write your slope-intercept form because you have a slope. Okay, you have the slope of 2, and you also have the y-intercept of negative 8. Okay, graph it in. It looks like that. Y-intercept here is negative 8, and it is a positive slope, so it's going up. There you go. That is 13. And that's good, I think. Yep, now we have the go part. Alright, go. Prove the two equations are equivalent by simplifying the equation on the right-hand side of the equal sign. The justification in the example is to help you understand the steps for simplifying. You do not need to justify your step. I'm going to be justifying my steps for you. You don't have to. Number 1 is always to write the equation. Why do you write your equation? Helps your brain organizes the equation, tells you which one you're going to work with. Okay. First step, I'm going to distribute because I'm trying to get rid of that parentheses. That is what happened here. Right? 2 is multiplied to the 3x and 2 is multiplied to the 1. That is how I got these two terms here because I am distributing. Okay. Then I simplify. 2 times 3x is 6x. 2 times 1 is 2. So this came from this. Good? Next, you want to combine the variables of the like terms. So I had the negative 10 here. Right, the negative 10 here was purple, and the 5x here is also purple. Right, and the 6x. Right, 5x plus 6x minus 10x gets you 1x. Okay, that's what you're gonna do after you combine the variables. Combine the constant. So your negative 7 plus 2. That's your green. Okay, that gets you negative 5. Right? Do you see how the left hand side matches the right hand side? So the left side does equal the right hand side. Okay, just be very careful when you're combining your variables or constants. 15, same process. You write the equation. Parentheses is always what you got to deal with first. So I'm going to distribute. The negative 10 here is distribute to the 2x. There you go. Negative 10 distribute to the 8. Negative 10 distribute to the 8. Right? Next, negative 10 times 2x is negative 20x. Negative 10 times 8 is negative 80. This came from this step. Okay. Alright, combine the variables like the terms on the right hand side. So again, you have 7x, negative 20x. Together, that gets you negative 13x. Combine the constants. So these are your constants here. Negative 80 plus 60 plus 24 gets you plus 6. Alright, the left hand side equals to the right hand side. I just did some rearranging. Okay. Number 16, you write the equation like before. Oops, misspelled that. Alright, distributive step, -3 times -4x, and -3 times -5. That, right here, this whole thing came from the distributive step. Okay? -3 times -4x is positive 12x. -3 times -5 gets you a positive 15. Combine the like terms. So what did I do here? That should be purple. 2x plus 12x is 14x. Alright, how did you get the plus 2? I combine the constants, which is going to be in green. 15 minus 13 is 2. That's your combining the constants on the right hand side. Left side equals to the right hand side. Next one, 17, you write the equation. Distribute, so 6 times x, that's how you got that. 6 times 3, that's how you got that. -5 times x, that's how you got that. And -5 times 3, you get that. Okay. Alright, you simplify. 6 times x is 6x. 6 times 3 is 18. -5 times x is -5x. -5 times 3 is -15. Combine the variables like terms on the right hand side. That's how you go. 18 minus 15, that's how you get your 3. You're combining the constants on the right hand side. On the right, that is your constants. Right, so simplify. X plus 3 is on the left hand side, and x plus 3 is on the right hand side. 18. Write the equation. Again, I am just distributing here. 7 times 2x and 7 times 1. And -3 times 3x, -3 times 1. Simplify from the distributive step. 14x plus 7 came from this part. -3 times 3x minus 3 times 1 gets you this part. Okay. Combine the variable like terms on both sides. So you have this. This is the only part I'm going to play with, okay? Because this became your -14x. Oh, sorry. Oops, sorry. This became your -14x. -5x minus 9x becomes -14x. Why do you do that? Because I'm going to add 14 to both sides. Do you see how I both have a 14x and a 14x on both sides? Okay, combine the like terms here. Oh, sorry. Okay, 7 minus 3x gets you your 4. Right? Did you see why I moved the 14x over on the left hand side? Because I wanted a variable on both sides of the equation. Okay, 4 plus 14x equals to 4 plus 14x. Okay, left side equals to the right hand side. Alright, that's why I didn't combine the whole thing. Once I made that 14, -14, I could bring it to the other side. 19, write the equation. Do the distributive property, -3 times x, -3 times 4. Okay. Right? That is what you got from the distributive step. The distributive step allows you to get rid of the parentheses. Alright, combine the like terms. What do I mean by the like terms? That was one of them. 4x, 3x is the other one, and I think 8x was the other one as well. 8x minus 3x minus 4x gets you an x there. Plus 12 to both sides, you should get an x plus 12. Right hand side, you get a 12 plus x. Rewriting it a little bit, you get the left side equals to right hand side. Alright, 20, write an expression that equals x minus 13. You must have at least 2 sets of parentheses and 1 minus sign. Verify that it is equal to x minus 13. So you start out with the original equation, x minus 13. I make, an expression. I make it an equal sign. I make it an equation by setting itself to itself. Okay? X minus 13 equals to x minus 13. That is positively true. I want to break down that -13. How do I make a -13? Do you see how 13 is going to be broken down into 20 minus 7? Okay? You could also do like 21 minus 8. Doesn't matter. Okay? Alright. Good. Now I want to break down the x into 2 parts. So how do we get x? I could do 3x minus 2x. I could do 5x minus 4x. Didn't matter. Okay? Or you could have, right? You could have even done 0.0, right? 0.5 plus 0.5, right? Still worked. That plus, right? That still worked, Okay. All right. That's your answer. Okay. All right. There you go. Left hand side equals to the right hand side. Just wanted to show you that the distributive step is just a way for you to break down a term. Okay. All right. There you go. Those are all your homework solutions for the Ready, Set, Go for 2.5.